Hi guys, and welcome to this new tutorial Blender Geometry Notes. Today I'm going to show you how to make a fully procedural highlight system which can be used in your project like motion graphics, photogrammetry, spots, or simply to better learn something from mathematics and Blender. So let's get started. I'm working with Blender version 3.4.1 and the idea behind this project is to have a collection of objects that you want to highlight with an animation, for example, and for this we need to create a new collection in your blend file, collection of objects. You need to add with a Shift A plane like this, press plus up general and geometry nodes, create a new geometry node system with the new button, and here we are. Move the plane outside the objects collection and rename it in highlight system. This will be our highlight system that will contain all the nodes that we need for our purpose. So first of all, you need to decide what object you want to highlight, or if you want to highlight the entire collections of objects. So first of all, I need some meshes in these objects, and for this reason I selected this collection, press Shift A and add a cube. I add a cylinder and move it to the x-axis a little bit. I add a torus and move it to the opposite side. Perfect. And these are our objects that we want to highlight. Select the highlight system, and for this we need to add a collection info node in our geometry nodes. Press relative because we want to get the original position of each object inside the collection. We can export the collection, so we can select from this part of the geometry node system. We need to export also the separate children if we want the entire objects as one instance, or limit the selection for one only object of the collection. In our case, I set one here to the separate children. Now we need to select our object. So for this reason, I need to use an index to select our object. And for this, I can add a group input node here. I can add to the group another new attribute, an integer attribute that we call index from 0. And if we want to not go over the entire number of the objects inside this collection, we need to count the total number of these objects. And to do this, we need to add a domain size node, and we can connect this geometry output of this collection info to this. We can select from these menu instances, because to the output of this geometry we have instances and not mesh. So for this I have the instance count, because you know that the indexing of these objects inside the collection starts from 0 and not from 1. We need to subtract from this instance count 1 to get the maximum index of our collection. So we have here 0, 1 and 2. This result is 3, so we want to subtract 1 to get the maximum number of index, so 2. Now we can use a switch node to select the correct integer number, and if the index that we set in the group input here is greater than the maximum index get from this subtract value, I want to use the maximum index, always the maximum. So if we set here 500, I get always 2 in this case. Otherwise, I want to use the correct index that I set. I collapse these nodes a little bit, enable the snap tool here, the snap node here, drop the connection between the group input and group output, and next in the final step we will see how to add multiple of these geometry nodes in the same stack of modifiers. So I drop this with the Ctrl and right button drag. I move this a little bit. Now to select the correct instance geometry of our collection, we need a separate geometry that can help us to get the correct selection of the geometry we want. And for this I need to link this geometry input, select here the instance because we have instances from this output, and we can't connect directly this switch to this selection because we have a boolean result here. So to have a good behavior, we need an equal mathematical operation from this index selected and the index itself of each of these instances. I connect this result here in the selection, and here Blender goes in this direction to get the index of each object of the collection and calculates the equal mathematical operation with this switch output. And if the index we set here is equal to the index, I get the correct selecting geometry here. And here I can connect the selection output to the group output. And for this reason, you can see if I set 0 in this index attribute, we can get a new copy of the cube. If I select 1, I have a new copy of the cylinder, and so on. Now I can select all these nodes here, press Ctrl J, F2, geometry, selection. Now, next part, delete the face that is not oriented to the camera. So to do this, we need to understand how we can leave the correct faces pointing at the camera and delete the other faces. So to do this, I will draw here the idea. So you can imagine that we have a camera here and we have a cube like this from the top view. We need to delete these faces because are not pointing at the camera. So to do this, we need two things. One is the vector between the camera and each face. To do this, we need to calculate this vector, and another vector that is this, and another thing is get the normal of each face to apply some mathematical operation to know what faces are pointing at the camera. So I draw also these vectors here, and you know this. You know that the dot product is a good mathematical operation that is defined like module of a vector by module of b vector cosine of alpha. Alpha is the angle between the two vectors, and you can see here we have this angle because this vector pointing in this direction. Here we have this vector, here we have this vector, and here we have this vector. The normal is always with a module of 1, so this doesn't care. The dot product can give me this number, so a value from -1 and 1. If I normalize these two vectors, it's obvious. So first of all, I need to calculate this orange vector. It is the vector that starts from the camera and goes to the position of each face. To get this vector, you know that if you have an origin of coordinate system, a vector like this, that is, for example, the position of the camera, and here we have the vector of the position of the face, you need to get this vector. So to do this, we need to subtract from this vector, and if you see the correct flow of the adding operation, so this flowing, you can see that if you add from this vector, you get this vector results. So for a moment, if we have a vector and b vector, and here c vector is equal to a vector plus b vector. So in this case, to get the correct b vector, we need to do c vector minus a vector. So in our case, the c vector is the position of our face and a is the vector of the position of the camera. So in this way we get the correct orange vector, and this green result is the normal of each face. So step by step, we need to capture on our selected geometry for each face what the normal vector. So we need to select the vector here, link the normal here, and because we have here not a mesh but an instance, and you can see it if I press Shift Ctrl and click here, you can see it here in the spreadsheet, one instance. So before the capture attribute, we need to realize the instance here, otherwise we can't save the normal information for each face of our mesh. So select all these nodes, Ctrl J, F2, save original faces normal, and we also need to save the normal of each point, because next we will use it to offset the new copy of the mesh to have an overlapping of the material assigned to this new copy of the mesh. Otherwise you would have a collision between the original assigned material and the material assigned to the copy of the height highlight mesh. So to do this, we need a capture another time here in between. For each point, we want to save the vector of the normal. And because we already have a correct meshes realized, we don't need another realized instances. Select all these nodes, Ctrl J, F2, save, original, points, normal. Now that we stored this information, we can calculate the vector from the camera and each face. So to do this, we need a new sample index that is the equivalent node of the transfer attribute of the previous version of Blender. So in this case, I want to get for each index of our faces the vector of the position, and this is the same structure of all the transfer attribute of Blender. Here we link the geometry, and from these we need to subtract from this vector the vector position of our camera, so we can add in the group input node a new attribute that is our object, and in our case the camera. So for this reason I can link this to the object info node and link the location of our camera to this subtract operation. Collapse this, use the relative position of the camera and not the original, because we can move this camera where we want. We can select all these nodes, Ctrl J, F2, calculate vector from camera, and in this case we have all vectors that start from the original position of the camera and go to the position of each face. Now we need to filter only the faces that we need. So to do this, we need to normalize this vector, so we can press here this normalized. The normal of each face is already normalized, so we need only the input node here, and instead of using this node here, we need to use the original saved normal here. So we need to use the dot product described before, and now I'm going to explain why this dot product. Connect this normal here, create a little dot to help us understand the layout, and here we are. This is the case. So we need to calculate the dot product, because the dot product can give us the cosine of the alpha. So if we have two parallel vector, we have 0 degrees and the cosine of 0 is 1. If we have these two vectors here, we have 90 degrees and the cosine of 90 degrees is 0. If we have two opposite vectors, we have 180 degrees, so the cosine is -1. And again, if we have 270 degrees, we have cosine of alpha again to 0. So imagine that we move these cases here in this coordinate system. From 0 to 90 degrees we have positive number. From 90 degrees to 180 degrees we have negative number, because we have 0 and -1, so the numbers in between these. From 180 degrees and 270 we have another time minus values and positive values in this case, so from 0 to 1 in the last part. So with this knowledge you can see that in this case we have here and here negative number here, because we have more than 90 degrees, not yet 270 degrees here, but less, and here we have positive number. With this information we can easily ask if the dot product is greater or equal 0. So in this case and in this case I want to delete the geometry of my mesh, and here we can select this result, and I don't want to delete the points, but I want to delete the faces, and this is the result. If I press Shift Ctrl and click, select the camera that I need and select the highlight system, you can see the correct new mesh here. And to better see it, I hide for a moment the original objects in my collection, and this is the result. And if I move this camera around the cube, you can see the correct deleting operation of our dot product. The same for the cylinder. So if I set 1 here, you can see this result here, and if I set 2, you can see for the torus the correct result of this operation. And if I press 0 to see see from the camera the result, you can see a perfect mesh pointing at the camera. And if you want to move around the camera, and you can try to do this, you can see if you lose the camera moving with the point of view, you can set 0 to go to the camera, press N, go to view section, and here you need to check camera to view to hold the camera with the point of view. Press N, and now if I move the point of view, the camera changes its position, and you can see a perfect alignment with the delete operation of our geometry nodes, also for the torus and the cylinder. Now I go here, I set 0 to this index, I can select these nodes, Ctrl J, F2, filter, faces. Now that we have this result, we need to offset the position of each face along the normal of the points that we stored before in the geometry. So to do this, we need a new attribute in our group input. So we need a float value that we can call offset from 0 and not negative number, it's obvious. We can add a new group input to our geometry nodes, add a vector math node to scale what the normal of each point that we saved here by this new offset attribute to have more or less offset in the space. We can create a new dot in between to have a better result layout. We can press Ctrl H. Now we need to set the position of this new mesh, where we want to offset these along the normal of the position, and you can see anything because we have no offset. So if I increase this offset a little bit, you can see this offsetting, and if I show the original cube, you can see the difference between the original and the highlight system. Next, we want to assign a material to this filling part, and to do this we can store name attribute here 2 times with the Shift D to save what. For example, we want to save the color and transparent attribute for each point of our mesh, and to do this we need to add to our group input another attribute that we can set a color and set the color here, and another float value that is the transparent attribute from 0 to 1, because it's obvious the transparent value is always from 0 to 1. Add a group input another time here and connect the color here, but before this we need to set not float but a color attribute, a color type here, and here the float is correct, and next connect the color attribute here and the transparent value here. We don't need to save anything in the output attributes because in the group output we have no attributes added. And for the final step of this filling part, we need to set a material here, and we can export this material to the group input and call it fill material. Now we can set for example a color of full red, no blue information, transparent to 0.5, and we need to add a new material here, and I suggest you to add the materials inside the highlight system, because if you want to import this entire system in your project, you will need only to import the highlight system mesh, and the materials will be imported at the same time. So we need to go fill material here and go down to this viewport display, and instead of blend mode opaque you need to set alpha hashed, and also for this shadow mode, otherwise you can see the transparent feature of the shader. Now that we have this fill material, we can go here in the geometry nodes and select fill material here, go to shading, and here we can set the correct attributes of this new material. So for this we can add the attribute, and we don't need the principal BSDF, but we need to add add an emission because we want to highlight the mesh. We can use the emission, we can use a transparent node here, shift, control and right click to mix together these two shading, and we have here a factor. The factor is our attribute of transparent that we saved before, and we can link the factor directly here in the mix shader. We can duplicate this with Shift D to get the correct color information and link the color information in the color of the emission and link the shader to the surface of the material output. And this is the result. We finished the filling part of our highlight system. Now next part, from this filling mesh we need to extrapolate only the boundary of this entire new mesh. So to do this we can select all these nodes, press Ctrl J, F2, get fill part. Now to get these boundary parts we need to hide for a moment the original cube and see the result of our copied mesh. And now if I press Shift Z, you can see that each of these edges is connected to one or more faces. So we can isolate this count number, and in this example this edge is connected to only one face, this edge is connected to only one face, but this edge is connected to more than one edge, so exactly two faces. And for this reason we can add a edge neighbors that gives us the face count where each edge is connected, and for this reason we can ask if the connected face count is greater than 1, I want to delete what? I want to delete the edges of my geometry, and for this reason I can get the edges connected to only one face, and this is very easy to do. Now we can convert this mesh to a curve because we need to use the trim curve, and I suggest you to use a minimum Blender version of 3.4.1 because with the previous version you need to add lots of node to solve a problem that I described in video to the top if you want to see it, but in this case we are very lucky. So to better select this start and end we need to add two attributes in the group input. So two float values are trim start from 0 to 1 and a new trim end always from 0 to 1, and we can add a group input in our workflow and connect the trim start and the trim end here. I set the trim end to 0.8 for example. Now described before, we can store for each of these point the color that we set here in the filling part, and we can name it in the same way. And also we can add a new store name attribute, so the float value of the strength of the emission of our shading, so we can add a new strength attribute from 0 and link this new attribute to this store name attribute. Final step, set material for the border for this boundary, and for this I need to add a new material, so I can press plus in the stack of this material, select the fill material, click here to create a duplicated of this original material and choose border material. So in this case I already have the alpha hashed and the alpha hashed in the shadow mode. I select this from this menu. No, I need to export this in the group input and rename it in border material. Now I can go in the shading editor, select these geometry nodes, select the border material here, and now I can delete the transparent node, the mix shader node, move this transparent attribute here and rename it in strength to get the strength attribute that we stored before, and link the factor directly in the emission attribute of the emission material. And if I set 50 for example and go in the geometry nodes, you can see anything. Why? Because here before the store name attribute, between the trim curve and the store name attribute, we needed to create a real mesh. So we need to move these a little bit here and convert the curve to mesh using the fill caps and using, for example, a circle curve. Here we can link this in this case, show the material preview with this button, decrease the radius, and we can export the radius in the group input. So I create a new attribute from this stack and not dragging this attribute because we don't need to have a unit measure. So if I drag from this attribute, Blender will add the unit measure to my new attribute. So I don't want that. I want to add a new float value. I want to call border radius from 0. I want to move it up and link the border radius here. I can use for resolution for this curve circle because in almost all the cases you would need few resolution for these meshes. Now if I go to this geometry modifier, I can set a border like 0.4 for example. Is too much, I can decrease it, and now that I have the correct boundary part, I can select all these nodes, Ctrl J F2, get border part. Now we need to add this boundary part to the filling part. So it's simple, we need a join geometry node here and link the filling part and the boundary part to this result. Connect this output to the group output, and this is the final result. We can show the original meshes to see these. We can decrease the offset a little bit, 0.017 for example, and increase the radius a little bit, 0.03 for example. And last but not least, if you go to 0 for the trimming, you can see this weird and bad result here. So Blender, because we have the fill caps here, shows this little part of the mesh, so we don't want that, and we can fix this problem asking if the start is equal to the trim value. So in fact we have here 0 and 0, and this is the correct switch that you can use for the filling caps. So if I link these, we have a wrong result, so we need here in between a boolean operation, and we want to set here the not operation or use the not equal in this mathematical operation. So I drop this not and select here the not equal operation, and now if I increase the trim end a little bit, I can see the correct filling caps that I want. Now that is all done, we can go to the last part of this tutorial. This is more interesting. You can see here an only instantiated node of these geometry nodes that I can call highlight system node. And imagine that you want to animate and use in a parallel way this system not only for this mesh but also for other mesh using a different parameters here, so different color, etc. So to do this we need to add another time this new node. But look what happens if I duplicate this node another time and select for example one index. You can see you lost the original of this highlight system on the cube, and this happens because using this node we lost all the previous output of the previous nodes. So we want to maintain the correct result of the previous geometry nodes highlight system node, but deleting the original plane that we added in the initial point of this tutorial. So the plane, in fact, if I go here before the group output, add a group input here and use a new join geometry here and connect the original geometry, you can see this union between the output of this geometry node, that is the new group input for this geometry node, and if I change this color, the effect is correct. But we have a problem with the original geometry. So if I press Shift and Z, you can see here we have the original plane we added in the initial parts of the tutorial, and we don't want that. We want to identify the correct new output that we want to connect to this join geometry. And to do this, we can easily store a new attribute to the output of our filling and boundary part, and we can save have a Boolean checked value named highlight, and for this reason we can add a name attribute here with the same highlight value. So Blender identifies that this is a Boolean attribute, and we want to delete from the group input geometry, so this geometry input, only the points of our mesh that hasn't this checked attribute. So if I link these, you can see this result. I have the initial plane that has not an highlight checked attribute. So Blender deletes the geometry here in the stack for the first geometry nodes. So for the first output, I have no output here, no plane. I have only the result of the first geometry node system, so the highlight of the cube, and we store the highlight checked value here. We have an output on this link, no output here, and the geometry is the result of the cube. Next, this result of the cube will be the new group input geometry for the second geometry node modifier added here. And if I want to ask me, is there any point without the highlight checked attribute? No, all the points of this input have this Boolean checked attribute, and for this reason it remains in this link and it will be added with the new output of the second geometry node system here, and the result is this. I have the result of this first geometry node and this second geometry node, and you can add whatever node you want here, and you can animate these nodes separately. You can also set 0 to these separate children, but it's obvious the result here in between the cube of the first geometry node and this second is weird in this case, unless you increase, for example, the offset of the red, and for this reason you can see this double effect, so the red and the blue effect, so you can animate these in a separated way from the trim and of the second geometry node added, for example. Now we can use the Ctrl H to collapse and organize our workflow. Select all these nodes, Ctrl J, F2, Cascade, System. And before discussing the way you can import this highlight system in your project, I want to add a little new piece of workflow, and I want to add these here in between the mesh to curve and trim curve. Why not adding an inverted direction of the curve? So we can add a last attribute here, a Boolean operation, inverted direction. I thought of this attribute in this moment while recording this tutorial, and we can add this here, and we can add a switch operation where we can move up the inverted direction, and if this is true, we want a reverse curve result here, otherwise we want the original curve. For example, press Ctrl H here, we can press Ctrl H here, here, and here for the camera and for these two initial group input. Perfect. So in this way I can invert in a easy way the direction of my curves. You can see this different effect. And now if we want to add this highlight system, I suggest you to do these two things. One is to save a base Blender file, disconnect the collection and the camera of one only geometry nodes, so delete the others, leave the fill material and the border material selected here in these geometry nodes, save the file, and from now if you go to file, create a new general file or open your file if you want, add your mesh, in this case a torus, and you can go to the file, link or append menu, select the blend file of your highlight system base file, go to the subfolder object and double click to the highlight system, and this will add the highlight system mesh with also the two materials described before, the fill material and the border material. Select the collection you want, so we need a new collection here that we can call object, for example, drag the mesh you want, select the collection in this modifier, select the camera you want, go in this to view the previous material, press 0 to see the result from the camera, and you can see if I change the offset in a correct way, you will see the correct result. And this was the tutorial. So thank you guys for watching this video. I hope you like it. If you like what I'm doing, please subscribe to my channel and check the bell icon to get the notification of all new posted videos. You can download this project from my Gumroad page or create these from scratch. I hope you learned something new from this project. Have fun and see you to the next video. Bye!